Welcome to this Maths Made Easy video on inequalities. To start with, let's take a look at set notation. Now you may be asked to give your answers to inequality questions using set notation, so it will be useful to learn the following. We use curly brackets to represent a set. So for example, let's say we've got the following, so x is greater than 5. So the way we read this here is the set of values of x such that x is greater than 5. Okay, so important to note here that we use curly brackets to define a set. The empty set is denoted using this O here with a slash through the middle like that. Okay, so this is what we call the empty set. And this just contains nothing. The intersection, which you will already come across when studying Venn diagrams, so the intersection, and this is denoted using a funny looking N here. Okay, so symbol for this is an N like that. Okay, and this tells us two sets contain only the elements present in both sets. Okay, so the intersection denoted using this symbol here of two sets contains only the elements present in both sets. And finally, the union here, so the union, and again, you might have come across this when studying Venn diagrams at GCSE Maths, is denoted with a funny looking U shape. So it looks like that, okay? And the union of two sets contains all elements contained in either set there, okay? So that gives us everything we need there for our set notation. Let's just take a quick break here to make the following notes. Now when we're adding or subtracting inequalities, the inequality sign doesn't change direction. Okay, so it's important to note that. When we're multiplying or dividing by positive numbers, the inequality sign doesn't change direction again. However, when we're multiplying or dividing an inequality by a negative number, the direction of the inequality sign changes. So it's important to note that. That can catch out a lot of students. So if we just make that note here for the final one, because that's the most important here. So when you're multiplying or dividing, so I'm multiplying here or dividing an inequality by a negative number, an inequality by a negative number, the symbol or the direction of the inequality sign will change. Okay, so it's important to note that. So the direction of the inequality sign this changes. Okay, so make sure you're aware of this. Okay, so that gives us everything we need there for our notes on inequalities. Moving on now to take a look at solving basic inequalities. Now, we solve inequalities in a similar way to how we would solve normal equations. We just need to be careful with the direction of the inequality sign. Now, if we take a look at this example here, we just want to find the range of values of x that satisfies 3x minus 5 being less than minus 1 plus x. It's important to note here that we also want to give the answer in set notation. Now the first thing I'm going to do here is add 5 to both sides. So I'm going to add 5 to both sides here. Okay, and by doing that, what we get here on the left hand side of this inequality is just simply 3x, and on the right hand side of this inequality we get minus 1 plus 5, so that's going to give us 4, and don't forget your plus x here. Okay, now here, as we treat this kind of like a normal equation simply, I want to get the x's onto one side of this inequality. So to do that, we can just minus x off both sides of this inequality here. So that's going to give us 2x. That's going to be less than 4. Okay, subtracting x off the left hand side and right hand side of this inequality. And finally here, all I want is x here. Okay, so to do that, we divide by the coefficient, which is 2. So in that case, we get x is less than 2. Okay. However, we want to give this answer in set notation, and remember for set notation we use curly brackets. So using curly brackets here, that's going to give us the values of x such that x is less than 2 here. Okay, So that's our solution there, using set notation. And let's just take a look at one more example here. So if we just clear this work in here, and let's just quickly write this question down here. So all I want to do here is find the range of values that satisfies 5 minus 5y being greater than or equal to 20. Okay. Now here, the first thing I'm going to do is subtract 5 from both sides of this inequality. So in that case, what I get here is minus 5y is greater than or equal to 15. Okay. Now remember, this inequality is in terms of y, but I only want y on its own. So we need to divide by this coefficient here of minus 5. And because we're dividing by a negative number here, the sign of the inequality will change the direction of this sign. Okay. So in that case, what we get here is y is less than or equal here now. So just be very careful for that. Less than or equal to 15 divided by minus 5, which would give us minus 3 there. Okay. It's important to note here as well that you can do the last part in more than one step, if that helps to understand why we change the sign of the inequality. So for example here, minus 5y is greater than or equal to 15. What we can see then is minus 15 is greater than or equal to 5y, and this leads to y being less than or equal to minus 3, which gives us the exact same solution here, but it might help just to visualize why that works. Okay. So in that case, that gives us everything we need there for solving basic inequalities. And finally, let's take a look now at inequality regions. Well, if we're given 2 or more inequalities, you may be asked to draw the region that satisfies all of them. Well, to draw a graphical inequality, we use the following steps. For step 1, we just simply treat the inequalities as equations in terms of y and x. For step 2 here, we simply plot the equations. But we've got to be careful here. We know that if we have the inequality symbols of less than or equal or greater than or equal here, we use a solid line. Okay, so use a solid line. And if we have the inequality symbols of less than or greater than, then we use a dashed line. Okay, so we use a dashed line. And for step 3 here, our final step, we simply identify the region where the inequalities hold true for. We then simply just shade the corresponding area. We shade the area above lines for y, or to the right for x if it is greater than or equal to. And we shade the area below lines for y, or to the left for x. And that's if it's for less than or equal to, of course. It's important to note as well that you can try coordinates of a point within the region to see if it also holds true for all inequalities. And then you know exactly whether you have shaded the region correctly. Okay, so that gives us everything we need there for inequality regions, and that concludes this Maths Made Easy video on inequalities.